Space. It's big, dark, and full of mysteries. For centuries, humans have looked up at the stars and wondered what's out there. We've sent rockets to the moon, robots to Mars, and telescopes to peek at distant galaxies. But what about asteroids? Those giant rocks hurtling through space might be the next step in our space adventure. Imagine living on an asteroid. It sounds like science fiction, but it could be closer than we think. Asteroids are like giant treasure chests floating in space. They contain valuable resources like water, metals, and platinum. These resources could be used to build space stations, fuel rockets, or even create new technologies. But living on an asteroid wouldn't be easy. It's a harsh and unforgiving environment with no air to breathe, extreme temperatures, and very little gravity. Plus, asteroids are constantly bombarded by tiny meteoroids. So while the idea of living on an asteroid is exciting, there are many challenges to overcome. But hey, humans love a good challenge, right? Before we pack our bags for an asteroid adventure, we need to understand what we're dealing with. Asteroids come in different flavors, like cosmic rock candy. C-type asteroids are the most common. They're dark and contain lots of carbon. Think of them as giant lumps of coal floating in space. S-type asteroids are made of silicate materials and nickel iron. These shiny rocks are like giant metal detectors in space. M-type asteroids are the rarest and most exciting. They're mostly metallic, with lots of iron and nickel. Imagine finding a giant chunk of metal in space. Each type of asteroid has its own unique composition, making them potentially valuable for different resources. Knowing what an asteroid is made of will help us decide how to use it. Not so fast! Living on an asteroid is a lot more complicated than just building a house on a rock. There are some serious challenges to consider. First, there's the issue of gravity. Asteroids have very weak gravitational pulls. Imagine trying to walk and just floating away. We would need to find ways to create artificial gravity or adapt to living in a low-gravity environment. Then there's the problem of atmosphere. Asteroids don't have atmospheres like Earth. This means no air to breathe and no protection from harmful radiation from the sun. We would need to create enclosed habitats with breathable air and radiation shielding. And let's not forget about temperature. Asteroids can get extremely hot during the day and freezing cold at night. We would need to develop ways to regulate the temperature inside our habitats. Living on an asteroid would be a continuous challenge, but scientists are exploring innovative solutions to make it possible. Mining asteroids sounds dangerous, right? That's where robots come in. Robots are perfect for the tough job of space mining. They don't need to breathe, eat, or sleep, and they can withstand the harsh conditions of space. Imagine a team of robot miners landing on an asteroid. Some robots would be equipped with drills and lasers to break up the rock and extract valuable resources. Other robots would be responsible for collecting and sorting the materials. These robots would be controlled by humans back on Earth or on a nearby space station. They would use their robotic arms and tools to carefully extract resources without damaging the asteroid. Space mining robots would be like our own personal space prospectors, venturing into the unknown to bring back valuable treasures. Section 5, From Asteroid to Spaceship, the Mining Process. So, we've landed on an asteroid and the robots are hard at work. But how do we get those resources back to Earth or use them in space? First, the robots would need to process the raw materials extracted from the asteroid. This could involve crushing, grinding, and separating the different elements. Next, we could use 3D printers in space to transform the processed materials into useful objects. Imagine printing out spare parts for our spacecraft or even building entire structures in space. We could also package the resources and send them back to Earth using reusable spacecraft. These spacecraft would act like space trucks, transporting valuable cargo back and forth. The possibilities are endless. With space mining, we can unlock the resources of the solar system and build a future beyond Earth. Section 6. Space mining, not without its problems. While space mining sounds amazing, it's important to remember that it's not without its risks and ethical concerns. One major concern is space debris. Mining asteroids could create a lot of dust and debris, which could pose a danger to other spacecraft and even to Earth. There are also legal issues to consider. Who owns the resources in space? How do we prevent conflicts over mining rights? And what about the environmental impact? Mining asteroids could disrupt their natural orbits and potentially even cause them to collide with Earth. It's crucial that we proceed with caution and develop responsible space mining practices that address these concerns. Section 7. Asteroids, homes or mines. So, can we live on asteroids, or are they just giant mines in space? The answer is maybe both. Living on an asteroid would be incredibly challenging, but not impossible. It would require overcoming significant obstacles and developing advanced technologies. Space mining, on the other hand, seems more feasible in the near future. It offers the potential to access valuable resources and expand our presence in space. Perhaps one day, we'll have both asteroid mines and asteroid habitats. Imagine a future where humans live and work in space, utilizing the resources of asteroids to build a sustainable future. The future of space exploration is full of possibilities, and asteroids will undoubtedly play a significant role in our journey beyond Earth. Section 8. Glossary of space terms. Asteroid. A rocky body, smaller than a planet, that orbits the sun. Gravity, the force that attracts objects towards each other. Atmosphere, the layer of gas surrounding a planet or moon. Radiation energy that travels in the form of waves or particles. Robot, a machine that can perform tasks automatically. 3D printer, a machine that creates three-dimensional objects by building them layer by layer from a digital design. Space debris, objects in space that are no longer functional, such as old satellites and rocket parts. Gap 3S. Section 9. The economic impact of asteroid mining. Asteroid mining isn't just a sci-fi fantasy. It has the potential to revolutionize industries on Earth. Experts believe that the minerals and metals found in asteroids could be worth trillions of dollars. Imagine a world where rare metals essential for technology and manufacturing are as abundant as iron. This could drive down costs and make high-tech devices more affordable for everyone. Economists predict that the influx of resources from asteroid mining could create entirely new markets and job opportunities. Companies are already investing in this futuristic vision. For example, planetary resources and deep space industries are developing technologies to make asteroid mining a reality. Futuristic projections suggest that by 2050, asteroid mining could contribute to a multi-trillion-dollar space economy. This economic boom could fund further space exploration, and even the colonization of other planets. However, we must also consider the ethical and environmental implications of this new frontier. How will we regulate space mining to ensure it's done responsibly? These are questions that the next generation of scientists, policymakers, and entrepreneurs will need to address. In conclusion, asteroid mining holds the promise of immense economic benefits, but it also challenges us to think about how we can balance progress with responsibility. The future is bright, and the stars are within our reach. Gap 3S, Section 10, about the author. Neil deGrasse Tyson is an American astrophysicist, planetary scientist, author, and science communicator. He is known for his charismatic personality and ability to make complex scientific concepts accessible to the public. He is the host of the popular science podcast, Star Talk, and has written several books on space, science, and the universe. Gap 3S, Section 10, the technological advancements for sustainable living on asteroids. As we look to the stars for new opportunities, the idea of living on asteroids brings both excitement and challenges. Sustainable living on an asteroid requires groundbreaking technological advancements. Currently, researchers are focusing on life support systems that can recycle air, water, and waste efficiently. NASA and private companies are developing closed-loop ecosystems that could make long-term habitation possible. These systems mimic Earth's natural cycles, ensuring that nothing goes to waste. Energy is another critical factor. Solar panels designed for space conditions could provide the necessary power for daily activities and mining operations. Innovations in energy storage and transmission are also crucial, as they ensure a constant supply of energy, even when the asteroid moves away from the sun. Protection from cosmic radiation and micrometeoroids is another hurdle. Scientists are experimenting with advanced materials and magnetic shielding to create safe living environments. Research in nanotechnology could offer solutions for self-repairing habitats, making them more resilient to space hazards. Transportation and mobility on an asteroid's surface present unique challenges due to low gravity. Engineers are working on specialized rovers and robotic systems that can navigate these rugged terrains. These robots could assist in construction, maintenance, and even farming. Speaking of farming, growing food in space is a hot topic. Hydroponic systems and genetically modified crops that can thrive in low-gravity environments are under development. These advancements could provide fresh produce for asteroid inhabitants, reducing the need for supply missions from Earth. The future possibilities are endless. Imagine asteroid colonies with greenhouses, research labs, and recreational areas. These colonies could serve as stepping stones for further space exploration, potentially leading to the colonization of other celestial bodies. In conclusion, while living on an asteroid may seem like science fiction today, the rapid advancements in technology are bringing us closer to making it a reality. The research and innovations happening now are laying the groundwork for a new era of space habitation. The dream of living among the stars is no longer a distant fantasy, but a future within our grasp. Gap 3S, Section 11, about the author. Neil deGrasse Tyson is an American astrophysicist, planetary scientist, author, and science communicator. He is known for his charismatic personality and ability to make complex scientific concepts accessible to the public. He is the host of the popular science podcast Star Talk and has written several books on space, science, and the universe. Gap 3S Section 11, summarizing our cosmic journey. Throughout this video, we've explored the tantalizing prospects of asteroid mining and living. We ventured into the composition of asteroids, discovering their rich mineral wealth. We pondered the feasibility of making these celestial bodies our homes, and met the robots designed to assist in such endeavors. We delved into the intricate mining processes and the potential problems that could arise. We questioned whether these asteroids would serve better as homes or mines. We navigated through a glossary of space terms to better understand our journey. We then examined the economic impacts of asteroid mining and the technological advancements essential for sustainable living on these space rocks. As we stand on the brink of a new era in space exploration, the challenges are as vast as the opportunities. The innovations in recycling systems, energy solutions, protective materials, and agricultural technology are paving the way for a future where humans might one day thrive on asteroids. The dream of living among the stars is no longer confined to the pages of science fiction, but is becoming a tangible reality, driven by the relentless pursuit of knowledge and the unyielding spirit of human curiosity. In conclusion, our journey to the stars is just beginning. The advancements we make today will not only enable us to mine asteroids for resources, but also to establish sustainable habitats in the harsh environment of space. The future holds endless possibilities, and as we continue to push the boundaries of science and technology, we get closer to realizing a future where humanity is a multiplanetary species. The cosmos awaits, and with each step forward, we turn the impossible into the inevitable. The stars are within our reach, and the journey is ours to embark upon. Gap 3S, Section 12, about the author. Neil deGrasse Tyson is an American astrophysicist, planetary scientist, author, and science communicator. He is known for his charismatic personality and ability to make complex scientific concepts accessible to the public. He is the host of the popular science podcast Star Talk and has written several books on space, science, and the universe. Section 9, about the author. Neil deGrasse Tyson is an American astrophysicist, planetary scientist, author, and science communicator. He is known for his charismatic personality and ability to make complex scientific concepts accessible to the public. He is the host of the popular science podcast Star Talk and has written several books on space, science, and the universe.